Hello, this video is for Math 161, 8.3 partial fraction decomposition. I'm going to go over 5 examples with you in this video. After I go over these 5 examples, 1, 2, 3, 4, and 5, I will have you to try these two all the way in the bottom. Now, I did post this PDF note. It's just a blank one. You can absolutely copy these on a separate sheet of paper. That's fine, but I just so that I can go over it over here, I made it into a PDF and posted it on Canvas, so you can just print it out if you want to, or you can just well, you do want to make sure you want to use a separate sheet of paper for these two problems because you will need more room than just this. But let's get started. Starting with the easiest one that I got here for you, number 1. Now, partial fraction decomposition is really separating a single fraction into 2 separate fractions, or 3, but the examples that I'm going to go over today, I'm just going to have you to break a single fraction into 2 separate fractions, okay? Now, the easiest cases that I will give you is when the denominator is already split. Or when the denominator is already factored out. So what you're going to write is this. Say that this is equal to, let me go ahead and use a pen. This equals the first fraction that has x minus 1 in the denominator plus the second fraction which has x plus 4 in the denominator. You see where I got these from, right? See where I got these from because the first factor is x minus 1, so I just made that into the first denominator, and the x minus 4 was the second factor, so I just wrote that as the second denominator. Okay, on top of these 2 fractions, just put a and b. Just put a and b. You're not doing anything with that 5x just yet. Okay, just put a and b. This is how we're going to get started on these partial fraction decomposition problems. Now, this is what we're going to do to both sides. Let me go ahead and move this one slightly to the right because I have a plan. Let me move this one slightly to the right because I have a plan. What we're going to do to both sides is we're going to multiply both sides by the denominator of the left side. So at this point, because my goal is to get rid of all the fractions, multiply the left side by x minus 1 times x plus 4. And the right side, and you see on the right side I have 2 rational expressions, so multiply this one by x minus 1 times x plus 4, and multiply this one by x minus 1 times x plus 4. Oopsies. Let me zoom out and show you the bigger picture right here, okay? So I just wrote down that I'm multiplying x minus 1 times x plus 4 to every fraction that I have. And at that point, I'm going to start canceling out some of the things that I'm multiplying and dividing. Take a look on the left side. X minus 1 cancels out with this x minus 1. And x plus 4 cancels out with this x plus 4. So what's the only thing that we have left on the left side? 5x. That's it. Equals. Now let's take a look at the very first fraction. Focus on this one. What cancels out? We cancel out the x minus 1 and this x minus 1. So what's left? We still have a. And inside this factor, we're going to write x plus 4. Okay, so what we have left is this. Let me highlight this, okay? What we have left is a times x plus 4, okay? And that's what I wrote down. Now, draw the plus sign. Now we're over here. Let's see what cancels out. The x plus 4 cancels out over here. And we're only left with b times x minus 1. So do write that. b times x minus 1. Okay, now our goal is to find what a and b is. Okay, now but we got a problem here though. If you take a look, we have a single equation with how many unknown variables? We don't know what x is, we don't know what a is, we don't know what b is. So we have 3 unknown variables, and this is not going to be good. So, but at least we know, at least what we can do is we can pick an x value. So this is what I'm going to do, okay? I'm going to do two different math, two different work, because I want to find what A is and I want to find what B is. On the left side, you take a look and think about why I'm picking this random number, okay? Let x equals -4. And you're like, why are we making x to be -4? Oh, you'll see in just a second. Now, everywhere you see x, take a look. Everywhere you see x, there is x here, there's x there, and there's x there. Plug in this -4, okay? And let's see what that will get us. 5 times -4 equals A times -4 plus 4. You see why I did that? Plus B times, move this line to the side a little bit. B times -4 minus 1. Let's continue, okay? The left side is going to be -20. Take a look. You will get A times what number? If you add these two numbers, you will get 0. Plus B times what number? -5. So let me simplify this, okay? -20 is equal to what happened to the A? If you multiply A times 0, that will cancel out. So that was the goal. When I picked x to be -4, my intention was to cancel out the variable A. And I saw if x is -4, then -4 plus 4 will get us to 0. So that's why I picked x equals -4. Let's keep going. If I rewrite this b times -5, that's going to be -5b. And you can divide both sides by -5. You get the first answer. b equals +4. Circle that. We're going to find the a value in a very similar way. We're going to find the a value in a very similar way, but we're going to have to pick a different x value, okay? Now, x equals -4, it was the 0 of this factor. Let me go and delete these pink highlights. What should I plug in this time so that b gets canceled out? Let me move over here. This time, let x equals +1, okay? And we'll see why. Everywhere you see x, you're going to plug in +1. Here, and there, okay? So that will be 5 times +1 equals a times 1 plus 4 plus b times 1 minus 1. You see why I picked 1, right? Because 1 was going to make this right here a 0. Okay, let's continue. 5 equals a times 5 plus b times 0. And if we get b times 0, that's just going to cancel out, and that's going to become 0, right? So this will cancel out, and we will have 5 equals a times 5. That's just 5a. Divide both sides by 5. You will get a to be 1. What am I doing? I'm writing a to be a equals 1. Now circle those a and b values. Now, don't stop there, because when you do partial fraction decomposition, you want to break down a single fraction into two fractions. Notice that I kind of wrote it down above. Let me write my final solution up here, okay? Take a look at this first fraction for me. I need to write it as a over x minus 1. I need to write it as a over x minus 1. A is 1. So my first rational expression will be 1 over x minus 1 plus, now what's the second fraction? Let's take a look. The second one has to be b over 4 over x plus 4. So let's write that down. 4 over x plus 4, and that is going to be your solution. Now, this is what you want to make sure to box when you submit your classwork. Okay, that's your answer. Don't stop after finding A and B. I want you to actually keep on going and find the partial fraction decomposition, okay? So that was the first example. I hope you understand that very first example. But let's keep going and let's try another one, okay? But it's gonna be very similar. All right, number 2. Find the partial fraction decomposition. But if we got a problem right here, notice how the denominator is not factored. The denominator needs to be factored first. Is x squared plus 2x. And this one, the factoring is not too complicated. As you can see, they have a common factor of x. Let's factor out that common factor of x so that you have x plus 2. The first thing you're going to need to do when you want to do a partial fraction decomposition is make sure the denominator is factored so that we can rewrite this as something over x plus something over the second factor of x plus 2. And just put a on top of the first fraction and b on top of the second fraction. So notice how this one we had to factor the denominator first, right? Now, let me move this work to the other side because I want to multiply both sides by something, right? So the denominator had to be factored out first. But here, what are we going to multiply to both sides? We're going to multiply both sides by x times x plus 2. That fraction gets multiplied by x times x plus 2. If I can squeeze in some work over here, I'm going to multiply the second one by x times x plus 2. And then this third last fraction by x times x plus 2, right? Okay, let's see. Now, all the way on the left. Well, you know, this was nothing. Well, we factored that and we got that to be x times x plus 2. So what happened all the way on the left side? Like everything cancels out. X cancels out. X plus 2 cancels out. So all the denominator terms got canceled out. We only have 2x minus 4 left. And that equals, let's go ahead and simplify the right side. Now notice the x and x cancels out. Therefore, we only have a times x plus 2 left. So do write that. A times x plus 2. Plus, go over here. What cancels out here? The x plus 2 cancels out, leaving us with only b times x. So that's going to be bx. Alrighty. Now we are at this point where we have to pick our poison to kill one of the variables. So let me start with my goal is to get rid of my a. Alright, let me get rid of a first. What would you like to set x to be? Let x equals -2. Why? Because if you plug in -2 here, -2 plus 2 will give you 0. And 8 times 0 will just be 0, right? So here we go. Let's plug in x equals -2 everywhere you see x. That will turn into 2 times -2 minus 4 equals a times -2 plus 2 plus b times -2. You okay so far? Let's simplify this then. Let's simplify. That will be -4 minus 4 equals a times 0 plus b times -2. The left-hand side turns into -8. The right-hand side, notice the a times 0 is now gone. I can write b times -2 as -2b. Lastly, we divide both sides by -2. Therefore, b is +4. So we found b. Now let's find a. What is our poison this time? What should we feed? to this equation so that b is gone. Notice, in order for this b to cancel out, we need to let x to be 0 because b times 0 will give us 0. So everywhere you see x, plug in x equals 0. That's how you will find your a value. Let's try that. Then 2 times 0 minus 4 equals a times 0 plus 2. All right, let me move a little bit to the right. Plus b times 0. All right, do simplify. Go ahead and simplify. I'm having so much fun with my iPad, guys. Okay, anyways, coming back, that's gonna be 0 minus 4 over here. So let me write negative 4 equals a times what number? 2. And that just turns into what? This is canceled out. B times 0 is just 0. So let's solve this. Divide both sides by 2. What's a then? A equals negative 2. All right, it's time for us to write the final answer then. Remember, to write the final answer, we need to go back to that one, the setup that we had in the very beginning. We need to write a over x, right? We need to write a over x. Then that will be negative 2 over x plus, then we need to write b over x plus 2. B is 4, so write down b over x plus 2. And that is your final answer. So just box that answer for me somewhere so that I can see that you completed the partial fraction decomposition. And that's how you do this. That's how you do this problem. I got 3 more for you, and essentially they're the same thing, guys. I'm just giving you a problem that has slightly more complicated denominator, and depending on what the denominator is, remember, you just have to always factor first. You're gonna have to factor the denominator to start the problem. So this one, it wasn't too bad. We just had to factor a GCF out, but you'll see the ones that I will ask you to try. You may have to factor a trinomial that has a leading coefficient greater than 1. So yeah, that's coming up. All right, let's go to number 3. Now this one, the factoring is not too bad. So take a look. The denominator is x squared minus 4x plus 3. So your job is to first factor this. Factor the denominator. Okay. So if I rewrite this, I will get 2x minus 4 over. Now factor this denominator, this happy x squared minus 4x plus 3. What's that going to turn into? That's going to be x and x. I need 3 times 1 to make it 3, but I need to make them both negative so that they add up to negative 4. So that's how we factor the denominator. It wasn't too bad. And we're going to set it equal to, the first fraction will have x minus 3. Put the plus sign. Don't forget the plus sign. And the other fraction will have x minus 1. And on the numerator, just put a and b. Just put a and b. Ignore the 2x minus 4. We're not going to use them now. So put a and b. Now remember, we're going to multiply both sides by the least common multiple. That's what it is, right? So let's multiply both sides by x minus 3 times x minus 1. All fractions get multiplied by that term. This gets multiplied by x minus 3, x minus 1, and also this one gets multiplied by x minus 3 times x minus 1. Alright, now time for us to cancel out some terms here. Notice how x minus 3 cancels out, x minus 1 cancelled out. We're only left with the numerator, 2x minus 4. And we're going to say that's equal to, let's see what's left over here. X minus 3 cancels out, right? So what's left? A times x minus 1. That's what's left. Let's keep going. Plus, well, this fraction right here, the x minus 1's cancel out. So we have b times x minus 3, b times x minus 3. Alright, I'm going to zoom out, and show you what we got so far. So this is what we have, and this is where we get to pick what to plug in to get rid of one of the variables. Now, what do you want to let x to be? I want to let x to be positive 1. Right? If I plug in 1 right in here, 1 minus 1 will give you 0. So let's plug in 1 everywhere you see x. 2 times 1 minus 4 equals a times 1 minus 1 plus b times 1 minus 3. Let's simplify. The left side, 2 minus 4 will give you negative 2. This will be a times 0 and plus b times negative 2. Notice this cancels out. Then you're left with negative 2 equals negative 2 times b. Then we divide both sides by negative 2. We got b value to be positive 1. So for that, let's find the the a value then. Let x to be equal what number this time? What should we plug in here to get rid of this b? X has to be 3, right? So plug in 3 everywhere. 2 minus 3 minus 2 times 3 minus 4 equals a times 3 minus 1. You will need to show me all this work when I ask you to submit these problems on your daily problem and on your take-home exam next week. Okay, let's see. If I simplify this, I will get 6 minus 4, 2. This will be a times 2 plus b times 0. That's what we wanted. So b times 0 will now cancel out, leaving us only with 2 equals 2a. So what does that mean? A must be equal to 1 again. Oh, A and B turn out to be both 1. Alrighty, guys, let's write the final answer for this partial fraction problem. Gotta kind of go back and search for your keys that you wrote down in the beginning. Remember, it was a over x minus 3. So I'm gonna write down 1 over x minus 3 plus, what was the second fraction? B over x minus 1. So 1 over x minus 1. And that's it. That is the answer for number 3. Alright, how you doing? Now, I got number 4 and 5. They're about the same difficulty, but these are the two that I'm gonna put on your daily problem. So number 4 and number 5. And that's all I'm gonna show you in this video. And after that, you will be ready for number 1 and 2 on your 2 problems to submit on Canvas, okay? All right, number 4. Do the partial fraction decomposition, but notice how, like, remember I asked you to practice factoring. Okay, but you know, I've been using the same method ever since the beginning of the semester, and you know how I usually do this. I multiply this 6 by this 3, and then I use this thing you call slide and divide method or bottoms up method. I get x squared minus 7x minus 6 times 3 will get me 18. And then I factor these two, remember? And then I factor these two. I'll get x and x. What times what give you 18? 9 times 2. I need to make 9 a negative and 2 a positive. But here's a problem. Remember, in the very beginning, we multiplied this number by 6. So now we have to divide both of these numbers by 6. I'm going to simplify this fraction first. That will be x minus 3/2, right? Times x plus 1/3. After I do that, I'm going to have to bring these denominators in front of these x's. That will be 2x minus 3 times 3x plus 1. And this is how I usually factor my trinomials when the leading coefficient is greater than 1. And it's up to you. If you like this method, use this method. If you don't like it, you need to figure out a factoring method where you can show me step-by-step work on your problem, on your exam, okay? So while that took me a little bit of time to rewrite the denominator, but now we're ready to do the partial fraction decomposition. But notice this work right there was just some, this is just our pre-work to get started on the problem. So let's actually do the precalculus. So write this 22 over 2x minus 3 times 3x plus 1. Write that fraction. Whoopsie, it's not 22 on the numerator, right? It should be 22x. And that equals, and I don't need to look at my factoring work anymore. The second fraction will have, the first fraction on the right side will have 2x minus 3. And then the other one will have 3x plus 1. Put a and b on the numerator, please. And after that point on, it's the same business, right? Now, let's multiply both sides by their least common multiple. Let's multiply both sides by their least common multiple of 2x minus 3 times 3x plus 1. Okay, and you see what will happen to the left side, right? But let me go and write those on the other side too. Now, you know what though? I'm really out of room. So I'm just going to go ahead and say these two are both getting multiplied by 2x minus 3 times 3x plus 1. And since you saw 3 examples already, you know what a and b will each have next to these letters. So let's simplify. Cancel, 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 cancel. The left side, we will only have 22x. Now be careful with the right side because I didn't write everything that you needed to see very clearly. But if I cross out the 2x minus 3, 2x minus 3, a will have 3x plus 1 next to it, plus, but if I multiply that same least common multiple to b, the fraction with the b on top, b will stay with the other factor, 2x minus 3. So that's what will happen. And now we're ready to plug in some numbers. And you see how it's not so easy for you to tell. Now the goal is this. I want to make sure this first fraction, this first factor turns into 0. So you know what? You can solve it. 3x plus 1 equals 0. Actually set it equal to 0 and solve for x. If I subtract 1, I'll get 3x equals negative 1. Divide both sides by 3. You found out that you're going to need to plug in x equals negative 1/3. X equals negative 1/3 to each term, okay? So let me do that first. Oh dear, I may need a calculator for this. Well, it's all right. Let's try 22 times negative 1/3 is equal to 8 times 3 times negative 1/3 plus 1 plus 3 times 2 times negative 1/3 minus 3. Okay, this line is way too close. So you have a scientific calculator to do your fraction operation. I mean, that is okay. Let me look around to see if I have a fraction with no, I don't have a calculator with me. I didn't bring it with me. It's all right. Let's do this. So I'll just do it without one, but you can use your calculator or graphing calculator if you want, if you have one with you. This will turn into what? Negative 22 over 3 equals, now I don't really have to do this factor. I mean, you know what that's going to turn into. That's just going to become 0, right? Because that's what the x value we assume that we really found the x value that will make that factor a 0. So without doing any plugging in, that's going to be 0. So a term is canceled out. So let me just focus on the b term here then. That's going to be b times negative 2/3 minus 3. So let me do some fraction work over here. Negative 22/3 equals b times negative 2/3 minus 9/3. Negative 22/3 equals b times negative 11/3, right? Okay, now we're ready to multiply both sides by the reciprocal. And the reciprocal is negative 3/11. Multiply both sides by negative 3/11. If I do that, these two will cancel out. And we'll get b equals, now look, the right side, a lot of things cancel out. 3 is gone. Well, 22 divided by 11 is going to give us 2. And notice we're multiplying a negative number times a negative number. So the sign should simply be positive. So a lot of ugly mess, but b came out to be 2. All right, let's go ahead and find a value, since now we have b. Something similar. I'm gonna have to figure out an x value that will make this factor a 0. So set 2x minus 3 equal to 0. Add 3, you get 2x equals positive 3. Divide both sides by 2. You know the x that you will need to plug in is 3/2, 3/2. Now, it may be easier for you to just use 1.5. I mean, in this case, you can use a decimal here, but let's just work with fraction. We haven't done too much fraction work without a calculator. All right, let's try. 22 times 3/2 equals a times 3 times 3/2 plus 1. Let me go over here. Oh no, I'm almost out of room. Plus b times 2 times 3/2 minus 3. But don't worry too much, because the b term will just turn into 0, right? Let's simplify this. The left side will turn into 66/2. No, I don't have to do that. Notice how I can just cross out this, not really crossing out. I can just divide this 22 by 2 and get 11. And 11 times 3 will give me 33 equals a times 9/2 plus 1. And tell me what happened to this right here. That just turns into 0, right? So b times 0 is that just cancels out. That's going to be gone. Therefore, I just need to solve this for a. Let's keep going. 33 equals, oh no, I should be quick. A times 9/2 plus 2/2. 33 equals a times 11/2. Multiply both sides by the reciprocal of 2/11. Multiply this side by 2/11. Then these two are gone. We get a equals, notice I can simplify this into 1 and 3. And 2 times 3 will give me 6. Or you could have just multiplied this and get 66 divided by 11. That gives you 6 too. So that's fine. So a is 6. And earlier we found a to be b to be 2. So let me write my final answer for this slightly longer problem. And if you're wondering, how do I write that fraction? The key was right here, remember? So all we're going to do is replace this a and b with the two answers that we found. So here we go. The final answer is going to be 6/2x minus 3 plus 2 over 3x plus 1. Okay, and that's how you do your partial fraction decomposition. And this is probably, I don't know, maybe not this bad, but I may ask you to try something like this on, probably not on the classwork today, but I don't know. I think you're capable of doing this. So that was number 4. I'm pretty low on battery, but I think I can do example 5 before this goes off. All right, last one for the day. But if you're okay with number 4, I guess you can stop the video now and try the 2 problems. But let me do one more with you if you need another example. All right, factor this. Factor the denominator first. Factor 2x squared minus x minus 3. And you know how I factor. I multiply the first coefficient, the leading coefficient, to the constant term. And just factor that. X and x. 3 times 2 is 6. And negative 3 plus 2 is negative 1. Remember to divide both of these by 2. Now, fraction divide all the way. So the first factor will be, notice I bring that bottom up right there if it doesn't divide. So that's going to be 2x minus 3 for the first factor. But you notice I can actually divide 2 divided by 2 into 1. So the second factor will be x plus 1. All right. You may need to, if this factoring is, like, if you need more help with this factoring work, you may want to look up some extra videos on factoring a trinomial with leading coefficient greater than 1. Because I do need you to be able to do that type of factoring by now, you know. So, okay. Now using that, let's break our single fraction of 2x plus 7 over 2x minus 3 times x plus 1 into something over 2x minus 3 plus another thing over x plus 1. So always do set that up for me, okay? Because I very often see students switching the numerator. A and B are correct, but they just put it on top of the wrong denominator. So just do set that part up. But let me go ahead and now multiply the least common multiple. And you know what? Can we do that in our head now? Let's try. Yeah. Everything will cancel out on the left side, and we're just going to have the numerator of 2x plus 7 left. What's on the right side? A times x plus 1 plus b times what? 2x minus 3. I know you can handle that. Alrighty, time for us to pick some x values to get rid of some variables. Now this one's easy, right? Let x equals what number? Negative 1. Oh, thank goodness, that one's not a fraction. Let's put negative 1 everywhere. 2 times negative 1 plus 7 equals a times negative 1 plus 1 plus b times 2 times negative 1 minus 3. Okay, let's simplify this. This will be negative 2 plus 7, a times 0 plus b times negative 2 minus 3. Left side is 5. Ooh, a times 0 is gone. Then I have b times negative 5. If I divide both sides by negative 5, I will get b to be negative 1. So I got that. Alrighty, now let's do the other one. And as you can see, the other one, we're going to have to put a fraction value in. Why? Because we want to make this factor a 0. 2x minus 3 must be equal to 0. So let's solve for x. And we were doing this. We just were doing that in our head. If it was just a x minus a number or x plus a number, we were just doing those in our head. But if it's a two-step, I don't mind if you write it down like I'm doing. 2x equals positive 3. So x must be 3/2 that we must plug in. Okay, so let's plug in 3 over 2 everywhere we see x. Okay, 2 times 3 over 2 plus 7 equals a times 3 over 2 plus 1 plus b times. Now really, I don't need to write all that work down. What should be the number in this parenthesis? That will just be 0, right? That's how we got that number 3/2 there. So, put the 0 there. We know that one's going to go to 0. Let's simplify this. The left side, I see the 2's cancel out. Left with 3 plus 7, that will be simply 10, equals a times 3/2 plus 2 over 2. I'm trying to add these fractions. So 10 equals a times 5 over 2. And what happened to this b times 0? That's just gone. Now what do you multiply to both sides? You need to multiply both sides by the reciprocal of 5 over 2. So let's multiply both sides by 2/5. Okay, so 5, 5, 2, 2, those are gone. We get a to be equal to, now look, this will be 20 over 5, or I can simplify this to 1, this to 2. 2 times 2, I'll get a equals 4. So let's write our final solution. Looking at the key that I wrote down up here, I need my answer to have a over 2x minus 3. So my final solution will be 4 over 2x minus 3 plus b over x plus 1. And b was negative 1. So I'm going to write it as negative 1 over x plus 1. You know what, guys? I can write it this way, or I can write, because you notice we're adding a negative 1 over x plus 1. So, if you want to, you can write this as the first fraction subtracting the second fraction. I guess that's okay if you want to. If not, you can leave it like that. They should be the same answer. So that's your final solution for number 5. I hope you learned this just now. It's not the easiest, but this is the last lesson for Unit 2. Next lesson, next class, I'm going to talk about Exam 2 review. And I will assign you a practice test to take on Alex. But for right now, I want you to try these 2 problems on a separate sheet of paper. I did say I want it by March 29th, Sunday. But please submit this early. Some people wait until the very last minute, and that's not going to be good. If you submit early, I'll let you fix any mistakes that you have, okay? So do these 2 for me. And when you're done and when you submit these, what you want to start on is you want to start on 8.3 Alex homework. 8.3 homework on Alex. Okay? Now that's it. Thank you for watching. Please email me if you have any questions. I'm still having office hours on Zoom, and the office hours are going really, really great. It's going to be like a Zoom video conference with you and I. I'll also scan this, and I'll actually post this note on Canvas, okay? But I do want you to, at this time, try your own